Hello friends, in this video we are going to learn how to find the mode of failure of riveted joints. Friends, you know very well, any of these riveted joints, either a lap joint or a butt joint, fails by three types of failures. That is, one is by the tearing of the plate between the holes. See, for example, friends, if we have a plate like this, two plates are there, one placed over the other, and friends, if it is subjected to a pull, the distance or the place or the gap between these two may get, teared off. So here we call such a failure as the failure by tearing of the plate, and we have an expression to give the efficiency of the plate eta p in general is f theta dash by f theta, where f theta dash is the strength of the perforated plate. A perforated plate is a plate in which the holes are drilled to accommodate the rivet. So here this is given by P minus D into H into sigma theta, where P is the pitch between two rivets, D is the diameter of the rivet, H is the plate thickness, and sigma theta is sigma T, that is tensile strength of the material of the plate or rivet, divided by F theta. F theta is the strength of the solid plate, a plate without any hole drilled in it for a pitch length of P. So that is given by P into H into sigma theta. Friends, all these expressions are readily available in machine design data handbook authored by any author. Now friends, here this is given by P minus D into H into sigma theta. Here sigma theta, the tensile strength gets cancelled, and this what you call H gets cancelled, and you are left with P minus D by P, and that we are going to multiply by 100 to get the percentage of efficiency. So this is called the plate efficiency. Friends, second you have got the mode of failure by shearing of the rivets. The rivets may get sheared off at the diameter D. So here that's given by eta R, which is called the efficiency of the rivets, given by the formula F tau divided by F theta. See the ratio of these two, both are the loads. One is the shear load, other is the tensile load. What is F tau? Friends, if you refer to handbook, it will be given by this I into pi d square by 4 multiplied by this is tau divided by the denominator is common, pH sigma theta. And here we should know the meaning of each and every term. I stands for the total number of rivets. Remember friends, in any joint, there could be all the rivets failing by single shear, such as in case of a lap joint, all the rivets failing by double shear in case of the riveted joint, wherein you have got the two cover plates having the same width. So here I stands for the total number of rivets in that joint per pitch length. Pi d square by 4 means the area of cross section of each rivet. This will give you the total area multiplied by tau, that is the shear stress, and this product will give you the load, divided by pH sigma theta. As usual, it is the strength of the solid plate. So say you will get some, again that has to be multiplied by 100 and you get some value. Finally friends, we have got this eta C, that's called efficiency in crushing or crushing efficiency, given in the similar form Fc by F theta. What is Fp? Fc is the crushing resistance. So that is given by the formula I d into H into sigma C multiplied This is crushing sigma c divided by p h sigma theta. You observe the denominators are common in all the three types of efficiency. Friends, here again I stands for the total number of rivets that is resisting this compression. D is the diameter, H is the thickness of the plate, D is the compressive strength, D is sigma c. I into D sigma c multiplied by this 100. So friends, here this is the area under crushing, and this will give you total area divided by the strength of the solid plate multiplied by 100 will give you some efficiency. So in all the joints, this is going to be the last step of calculation where you will be asked to find out what is the efficiency of the joint and what is the mode of failure of that particular joint. Say friends, in a problem, we have got this as 70.14, 61.07, this is 110.22%. Say, it is possible in case of the crushing generally to more than 100% or around 100%. Friends, you have got all the calculation made for the joint and you have calculated the three efficiencies as 70.14, 61.07 and 110.22 efficiency you have calculated. And now in the question we have got what is the mode of failure of this particular joint. Friends, based on this efficiency, we can just analyze and say what is the mode of failure. Friends, remember, this is a very important concept and this is applicable for any problem on riveted joint, and most of the times you will be asked to find out the mode of failure of that joint. Now, friends, say in these three, we have got the maximum value 110.22, minimum value 61.07. Now, say in these three efficiencies, the least of all of these is 61.07. That is the efficiency of the rivets. And we say that the efficiency of the joint is 61.07% and the mode of failure is by shearing off the rivet. And friends, say in some other problem, in a problem number 2, say you get an efficiency in the other way, or you say like this. So this has got some value. Say this is the least value you are getting. You have calculated all the three and you say you are getting the least value. And we say the efficiency of the joint is so much percentage and the mode of failure is by tearing of the plate, eta P. Plate gets sheared in between the two holes. For example, friends, if there is a problem wherein you get the efficiency, this as the least, say these are 70.14, 82.17, 61.22. Simply have taken for the purpose of explanation. Generally this will be more. Friends, here you can observe that eta C has got the least efficiency. And we say, after calculation of all these, that the efficiency of the joint is 61.22% and the mode of failure, that is if at all the riveted joint fails, it fails by crushing of the plate or of the rivet. So, I will just state once again, in any joint, if eta P has got the least value, then the efficiency of that joint is eta P value. And we say the mode of failure is by tearing off the plate. Second, if eta R is the least value, we say that the efficiency of the joint is that percentage and the mode of failure is by the shearing of the rivets. Finally, if this value is the least in a problem, then we say the efficiency of the joint is that percentage you get, that's the least value, and the mode of failure is by crushing of plates or rivets. Friends, I hope and I am very sure that you all got the concept about the efficiency of the joint and the mode of failure of a riveted joint. Friends, please go through the complete video, and if you like this video, Do share it with your friends without fail. Have a wonderful Sunday, and this is Dr. M. H. Annaya signing off.